Good morning, everyone. We are delighted to welcome you to another exciting online alumni session hosted by Good morning, everyone. Relations Cell. We are delighted to welcome you to another exciting online alumni session hosted by Good morning, everyone. Relations Cell. We are delighted to welcome you to another exciting online alumni session.
That's right, Kaushal. Before we dive into today's session, let's begin by acknowledging the presence of distinguished guests. A guest of honor, Mr. Arvind Shajapurkar. Accompanying him, we have Head of Mechanical Department, Mr. P.M. Patare Sir, and Alumni Coordinator, Professor P.A. Bosge Sir, our faculty members, and of course, our students who are eager to learn from the experiences of our esteemed guest.
We have a special address from Dr. P.M. Patare sir. He has a few words for encouragement. I request sir to please proceed.
Okay, then he will be joining us later. So we will start. So I would like to take privilege to acknowledge Mr. Arvind Shashapurkar sir's dedication to be here with us today. I am glad to tell you that he has completed his BE in Mechanical Engineering from Sanjeevani College of Engineering in the year 1993 and his ME in Piping Engineering from IIT Bombay. Currently, he is head engineering operations at Rishabh Software, Gujarat, heading a multidisciplinary team of 120 and carrying out pre-feed, feed, and detail engineering as EPCM for domestic and international clients in chemical, petrochemical, onshore and offshore oil, gas, and domains. He also has vast experience with companies such as Quanta Process Solutions Private Limited, L&T Technology. His journey is an inspiration to all of us. I'm sure we will gain valuable insights from his presentation. Now it's time to hear from our esteemed guest. Sir, the virtual stage is all yours. Sir, I will request you to start the session.
Am I audible?
Yes, sir.
Yes, sir.
Okay, thank you. So first of all, good morning to all of you.
Good morning,
Good
sir.
morning, sir.
Let me say thanks to Sanjeevani Education Society's management, Mr. Dr. Patare, and your placement cell to invite me for this webinar. And I'm equally excited to share my thoughts and experience with all of you. So it is basically a great journey I had, and I am completing almost 30 years after I graduated in the year 1993. So let me first introduce myself and my journey, and then basically I have not created any presentation in this webinar because I thought that sharing my thoughts and experience with you will be much easier in a vocal way than by any presentation. And in my this discussion with all of you, probably you will get some of the insights that I will be giving you that you can anyway Google search and understand on yourself. So I think that way it will be much better for me to interact with you, and I hope it will be an interactive session. I'm open for all kind of questions from all of you because you must be very excited to know what is this engineering design field. So let me start with my experience and probably you may correlate with this. So can I know what is the presence, what are the number, how many people are there, and from which area they are there, means right from the first year to fourth, or what is the mix? I wanted to know. So that I can make hello, I'm getting some disturbance.
Hello, sir. Sir, there are around 100 people, 100 students from second year mechanical department.
Okay.
Yes, sir.
Fine. Yeah. Okay. So I believe this engineering design field as a career option. I think you all must be interested to know, and probably you all who are 100 or maybe more who are sitting here must be eager to know what is this field and where we are going in India and what are the career opportunities in this. But of course, when we say career opportunities, what are the challenges? So how you can prepare yourself to create your own career in this field. So let me start with my journey first of all. So because now many people, they think that, and probably this kind of feedback sometimes comes to many people who graduate, that whatever we have studied in engineering is of not very much of use in actual field, right? So many of you must be getting these kind of feedbacks from seniors or something like that. And let me tell you, my opinion is totally different. Whatever you study, it is very, very useful in your career. Yes, sometimes if you choose a different type of career, then the question is different. But particularly in the design field, your basic fundamental knowledge matters a lot. So let me tell you now that when I say this, so what are those particular subjects that are generally useful in this particular thing? So I am taking this light little bit on the fundamental level, so that the people who are just starting their journey, like they are into second year, so they will put little more emphasis on those subjects. So my favorite subjects were actually metallurgy during that time, and hydraulics, then engineering drawing, then strength of material. So all these things people generally think, what is this in metallurgy? It's a what boring subject and all that. But it is not like that. If you have fundamental knowledge of couple of subjects, it helps you a lot in engineering design field. So let me give my introduction from the career that I started with from after graduating in 93. So during those days, basically 30 years back, India was not growing, and there were a lot of job challenges when we graduated. So I thought that let us try for a government job. So then I appeared for various exams and I got cleared. Mazgaon Dock Limited. So Mazgaon Dock Limited, is based in Mumbai, and it is basically a defense PSU, and it's engaged into making of warships and submarines. So I was into the warship division, and I spent 15 years in Mazgaon Dock, and I started my career from management trainee as a management trainee. And in various departments, actually, I worked in Mazgaon Dock. And let me tell you one funny incident. So when I joined Mazgaon Dock, the day one, actually, my general manager called me and he asked me that in which department you would like to serve. So at that time, and whenever generally people generally they graduate, at that time the name was R&D, that is research and development. So we thought that we'll go into research and development, so that will give a great boost to our career. And probably that was a fascinating word also, that you are working in R&D department. So I told him that I want to go into R&D. So he started laughing. So I go, why he's laughing? I don't know. He said, there's no such department of R&D in this. So I told him, what is this? You are creating such huge warships and submarines, and there is no R&D department. So, but anyway, he told me, you go into the piping fabrication shop and you start your career from there. So I go, okay, fine, no issue. Later on, I came to know that R&D was receipt and dispatch department in Mazgaon Dock. So I thought, oh God, if I would have been in that department, what would have been my career at this moment? But anyway, so that was the start of my journey. In Mazgaon Dock, actually, I worked in right from the start at the fabrication level, and I went on to, going into the design. So design was always a very passionate thing for me, and I wanted always to do something creative and using my engineering knowledge to create something creative and something new, and particularly for the country. So when I was there, so I got the chance to be in that department. And in engineering design, actually, I was into warship design. So India's first stealth warship, that is INS Shivalik. Actually, I was in the design team of that, and we did fantastic work in that. And afterwards, India now today, Mazgaon Dock is in news almost every day because they are continuously fabricating, and manufacturing these warships, which are very highly complex platforms. So after 15 years, trending into 15 years in there and understanding the actual engineering, how it happens, then I thought that let us move on, because sometimes being in government service for long is not good for the career, I believe, because then you become complacent. So then I thought to choose another way into my career, and I joined L&T. So in L&T, actually, again, I was into the design department of ocean engineering. So we were having ocean engineering there. So in ocean engineering, we used to do all oil and gas platforms designs, and and again ships design, marine platform design, and all that. So that also we executed a lot of projects there, and then moved into. What happened during those days? This marine industry actually went down, and there was a very heavy slowdown in the industry, and a lot of such design firms actually they closed their shop. So then I got a chance to again move into some different field altogether, and that was a plant engineering. And in the plant engineering, then I actually worked with a lot of oil and gas companies, particularly in Middle East, US, Canada, and Africa, and we executed a lot of projects there. So I traveled a lot, almost 17, 18 countries I traveled, and had a chance to actually interact with all the big names. I don't know how much you know, but let me just give some names. Probably you can search on Google sometime. Like Qatar Petroleum, Suncor, that is Canada's number one oil and gas company, Chevron, Shell, then in Angola, Sonangol. So almost all oil and gas companies I worked with, a lot of projects we executed. And then from there, actually, I moved into the chemical sector. In chemical sector, we created a lot of such designs for the chemical and so on. So today also now I am heading engineering department, which is a multidisciplinary department, and we are doing great work in oil and gas, petrochemical, chemical, and various such sectors, or water, wastewater. Very recently, we also have ventured into green hydrogen. So we already completed our first green hydrogen design project. So when I say this is okay, this is my journey, that's fine. So when I say what is design, a very different type of thoughts may come into your mind, that what kind of design I'm talking about. So you can, for understanding, you can divide this design into two groups. One is process design and another is product design. So when we say product design, so what is a product design? So product is any product. Maybe it is a motorcycle, scooter, a fridge, or TV, or any kind of such kind of a product that we generally use. So that design, it requires a different kind of skill. It requires different kind of softwares. It requires different kind of technology to carry out that kind of a design. And then the other one is the process design. What is process design? So where these products are manufactured, so the factories which manufacture such kind of projects, or products, the factories itself comes under the process design. Okay, so suppose you have to put up a factory on land, which is given to you as to put up some factory. So how you will create that factory? So in that factory, lot many things are there, right? There's just a barren land. So what you will do with that? And suppose somebody asks you that I want to manufacture some kind of product, let us a scooter. So what do I will do? So how that design happens, this entire factory design, so that we do. Okay, so that is called process design. So when we say process design, it's a very vast area. So in process design, anything comes under process design. Let us say oil and gas. So refineries are there. So refineries, then in oil and gas, then again there are multiple bifurcations into it, like upstream, downstream, midstream, downstream, and all that. So all this kind of, then offshore, onshore, and all that. So there is a wide variety of you can say field in which lot of designs happens, and every design again is a very peculiar in its own way, because there are various types of challenges in those designs. Let us say I will give an example. If you know what is Bombay High, which is very near to the Mumbai, where our actually offshore fields are situated. Almost 150 wells are there. So how this everything is happening? So in process design, we carry out entire design of that particular field, in which all the oil that is coming out from the seashore, from the sea depth, that comes into the jackets, and through jackets it goes into the platforms and all. So basically, this design that requires a lot of knowledge, a lot of codes and standards knowledge, lot of fundamental engineering knowledge. So if you guys suppose opt for such kind of a field where you want to go into this kind of area, then definitely it will help you a lot to explore this career. So this is basically on the design side. I would say the thing is there. Now, so if you have any question right now, you can ask. We can move it to the next one. Do you have any question?
If anyone is having question, feel free to ask.
I
You
hope
can
I
type.
am
You can drop your
clear
questions in
in
the
what I am
chat
saying.
box. Yes, sir.
Okay. Yeah. So now I will move into the next topic probably. So
Sure, sir.
that is yeah. So basically now we have talked about the engineering design field. So you must be now having some idea what I'm talking about. So now if we will see what are the challenges in engineering design. So when we say we are doing some design, so what are the normal challenges we generally have? Basically, it is a skill, it is a knowledge. Because in any design, if you do not have the right knowledge of that particular field or what you are applying to. Now I will give you an example. Let us say I want to use a pump, a centrifugal pump, and that centrifugal pump needs to be pumped. Some water it is pumping from some kind of a pond or some kind of tank to a level at some level. So how you will design this entire system? So basically, you must know how the centrifugal pump works. What is NPSH? How NPSH is getting affected? What are the parameters that affects NPSH? How you will calculate the suction depth, right? How you will calculate the pressure? How you will calculate the size of the pipe, right? Which material you will use for that? What kind of valves will be used in the suction side and the discharge side? How this entire pump will be operated? What will be the pump curve? What kind of instrumentation required to control this entire pump system, right? So there are so many things. Then there are electricals, or everything is there, right? So when we say where we are designing certain thing, so your knowledge of basic knowledge of all these systems and all these, you can say multiple disciplinary knowledge. It's not about just mechanical engineering, because today the way world is evolving, I would say that it is not now necessary to just have one discipline's knowledge. And you all guys are must be doing a lot of projects right now where you are using instrumentation and control and even the programming. So many times, like we also control this entire system or the process using PLC, that is programmable logic control. So or DCS, so which requires a lot of graphic designing and some programming into it. And nowadays, like as we say, it is on the IoT, that is industrial OT platforms, where all this data is generally given to the cloud and then remotely controlled and monitored. So all these things are now getting embedded into the system. So now only having the knowledge of mechanical engineering per se is not sufficient. So when you enter into the design field, your knowledge must be much greater and much vast than just a basic knowledge of mechanical engineering. So that is how actually today's colleges are providing these opportunities to the students, where they experiment and they experience this extra knowledge that comes from the software knowledge or something like that, where they can also do some programming which is required to control all this. So this is something a part of this design field. Now when we talk the challenges, so this is what is the biggest challenge we have. So when today people graduate from the college, they are not having this kind of a vast knowledge of various fields, and they come to the corporate world, where a lot of expectations are there. And the biggest challenge which we are facing today in the design is this design is ever evolving. Now, how many of you really know what is the current challenge this humanity is facing? So that is something like global warming. So when we say global warming and it is happening because of fossil fuels, So entire world is continuously evolving and trying to change its ways of using fossil fuel and going into the non-conventional fuels. So what it is actually creating, it is creating new technologies, and new technologies requires a lot of knowledge and lot of experience and lot of innovativeness. So when we say innovativeness, that comes from the creativity. So when you create something, you have that kind of thought process that you want to do something new or want to come up with an idea, so that can be implemented, and which is an implementable idea, of course. So that is how these things are evolving. So today, like, we are going into green hydrogen. So green hydrogen is something, a new area which is coming up at a very fast rate. So green hydrogen, blue hydrogen, gray hydrogen, black hydrogen, all this kind of blue ammonia, so all these areas are actually developing very fast. So when we are going into that field, so as an Indian, we must know that what is happening at this time in the world and how we are aligned to it. So let me tell you, during my experience of this 30 years and working with a lot of companies of repute in Middle East or in US, Canada, and Europe and Africa, we are actually very great people. We Indians are very great people, and almost I am interacting with an Indian only outside, and they are mostly at a very good positions. So basically, we Indians are almost everywhere now, and we are actually driving the world. We are doing great job into engineering and technology, and with that, really, as an Indian, I feel really proud that we are so great that we are actually doing such complex projects, and we are really helping world to diversify from the usual fossil fuel to the new areas like green hydrogen and carbon capture and all that. So this is something that now we come here. Then the challenges, it is basically what I was talking to you from the technical or technological point of view. Then the next challenge that comes to us is basically on the soft skill and software skills. So like as I said, that when we do a lot of design, so there are a lot of yeah, I understand. I'm coming to that. So I just saw a message. So when we say we are into design, so there are a lot of tools which are required in design. So what are the tools in mechanical engineering? I will divide these tools into two categories. One is the 3D modeling tool, and the other one is the analysis tool. So when we say 3D modeling tool, so these are the basic tools which are nowadays used for any kind of a design or creating the layout and the 3D models. So the first one is the SP3D, that is Smart Plant 3D. So Smart Plant 3D is a high-end software from the Hexagon, and which is generally used in most of the oil and gas industries, which are having very big plants. In SP3D, there are various modules actually. So you can pick any module. It is basically a piping module, it's a structural module, it's a foundation, SP3D foundation, where all the database, etc., is being created. So the SP3D is one. Second one is E3D. So E3D is also a 3D modeling tool from the Aveva. So this is basically almost equivalent to SP3D, but little less complex. Then the third one is CADWorks. So CADWorks is again a 3D modeling tool, which is used very widely in the world for carrying out 3D modeling. Then the another one is Inventor. Then AutoCAD Plant 3D. So these are all the 3D modeling tools where generally we create a 3D model, we rotate the 3D model, we go into it, we do walkthroughs, and then we make this entire plant look into a 3D. And then from the 3D, then we go into the further detailing on the 2D drawings and all that. So these are the 3D modeling tools. The other one is the analysis tool. So when we say analysis tool, in mechanical, you can divide mechanical into two parts. One is the mechanical and one is the piping. So when we say mechanical, so in mechanical, again, there are three parts. One is static, second is rotary, and third is packages. So when we say static, so a lot of static equipments designs are generally done. So what are the static equipment? These are tanks, these are reactors, vessels, pressure vessels, columns, heat exchangers, So these are all basic mechanical equipments, or you can say bullets. Bullets means storing bullets. So these are all high-end mechanical equipments which are generally used in any process industry or any industry. So there are a couple of softwares in this. So for the static design, the biggest useful software that is generally used in the industry is PVA Lite. So PVA Lite is generally used for this kind of a thing. And then there are E-Tank software, Comos is there, one software for static design. Then going into the piping design, generally piping design is done for stress analysis. So piping stress analysis is one of the area which is in the boom right now in the industry, and everybody want good pipe stress engineers. So Caesar 2 is basically the software that is generally used in pipe stress analysis, and it is widely accepted worldwide. So basically, these are the softwares I'm talking about. And now these softwares are just not something like you give input and get the output. It's not that kind of a thing. Basically, there are a lot of fundamentals goes into it. Let us say the static design or a vessel or a pressure vessel design and all that. So there are codes which are generally used. So you must have heard ASME. So all mechanical engineers generally know what is ASME mean, like American Society of Mechanical Engineers. So in ASME, there are three parts. So one part is B31.1, means B31, I would say. So B31 is basically for the process design of piping systems. So when we say B31, so it is B31.1, 31.3, 31.4, 31.8. So these are the codes, and 31.12. So these are the codes which are generally used in engineering. So mostly used code is 31.3. That is a process piping code. So it is a very big book, and if you go through it and if you know what is 31.3, it will be much easier to do any piping design. 31.1 is basically very high pressure and temperature piping for boiler systems. So these are only for boiler or limited area that is being covered by 31.1. 31.8 is basically gas transmission pipeline, which are cross-country pipelines. So we have to use 31.8. 31.4 is liquid hydrogen transportation pipeline. And then 31.12 is hydrogen. So these are the codes which are used in piping side. And then there are BPV code, ASME BPV code, that is boiler and pressure vessel code, part 1, part 2 and all. So fired and non-fired pressure vessels. So basically these codes are generally used to carry out static design. And then there are API codes, that is American Petroleum Institute. So API codes are generally used in various type of equipment design like tanks, vessels, and your heat exchangers, ACHEs and all that. So these are the codes which are generally used in any engineering design. So whoever from your end wants to enter into this field, they must have at least some basic knowledge or some understanding of these codes. It will help them a lot to really go into that area. The first thing, that is the codes and standard knowledge and the technical knowledge and how to apply the code. That is the experience that you have to gain. Then the second area that I would say is about this this software, where the administration of the software comes into play. So at this moment, across administrators are very few in numbers, and therefore if anybody wants to develop a skill, uh, okay, so I will come back to that. So basically, as I was saying, that this administration or administrative tools which are given in the software, basically what does that do? You cannot simply start doing any 3D modeling in any software. You require a database of that software. So how to create that database? So that is something a very great skill today. And every company, whoever is there right now, they are going into hiring this kind of people, particularly SP3D, E3D, or AutoCAD Plant 3D administrators. So these administrative, you can say, courses are generally being given from the various private institutions, and they provide this kind of thing. And I think there are a couple of companies in Pune or Mumbai who are there. Actually, they provide this kind of courses. It is something maybe 1 month or 1.5 month, 2 months, course where you can go into detail and understand how this administration works. So when we say, as I said already, that is not just the mechanical engineering that is required, but now the software, you can say coding or some kind of a software knowledge is also required today. Because when we go into more detail into this 3D modeling tools, there are various open utilities given. So in those open utilities, you can actually create some macros, and those macros helps to improve the productivity and reduce the time and improve the quality. So this is something you all have to really go into the details and understand. Now I will just give how. So now we'll give some glimpse of this engineering design per se as a field today, where it is and where it is going. So you will understand how the things are happening in engineering design. So as you all know that India is becoming almost fifth largest economy, like Modi ji is telling this every often. So and we are really doing it. So lot of investment is happening in India from in all the fields, and every investment will require what? Design, right? Without design you can't do anything. Without drawing you cannot do anything. For everything requires design first. So when we say, like during my introduction, she said, Sania said that I'm doing pre-feed, feed and detail and all that. So what is pre-feed, what is feed, what is this? So when we say feed is basically front-end engineering design. And when we say pre-feed, that is the means before feed. So when we actually do any plant design or any process design, so we have to create a conceptualization. And when you do some conceptualization of that particular plant, then only you can go into the detailing of that plant. So what is conceptualization? So when we, let us say, as I said, when we are having some kind of a piece of a land, and then you want to put up a factory on over it. So what will be the size of a factory? How the layout will look like? What are the different, let us say, utilities when I say? So there may be steam required, there may be water, there may be nitrogen, there will be instrument air, there will be compressed air, and there will be chilled water, there will be fresh water. So many things comes into play, right? Then all these things requires some space, some design. Let us say I would say that I want a cooling water. So what kind of cooling water you want? What is the temperature of that cooling water? How you will get it? Raw water you want? Where is the raw water? From where you will get it? Is it a ground or something from some pipeline it is coming? What are the different properties of that water and all that? So when we carry out this conceptualization, that is called feed. That is front-end engineering design. When this conceptual design is freezed, then it moves into the detail engineering design. So when we go into detail engineering design, there actually we incorporate or integrate all these technologies one by one and connecting each and everything and create this entire plant or whatever you are actually creating. So this is something you all have to understand. So when we do some kind of a conceptual design, there are a lot of codes which are required, particularly in India. Let us say, I will give some names, probably you can search them and you can have a little more information about them. So the first one is OISD. So that is Oil Industries Safety Directorate. So when we say what is OISD, so there are a lot of codes given in OISD, and in that there are so many things given how this entire plant looks like, should be look like. Then there are PESO, that is Petroleum Explosive Safety Organization. So when we store any such explosive gases or you can say liquids, so PESO approvals are required. So these are a couple of things which you all have to know little bit, and then you have to move into the design field. So I believe I have given you some kind of a glimpse of what is expected into design from the technical point of view, right? So is it clear? So I will move into the next level of expectations from the people today.
Yes, sir.
Yes, sir. Definitely.
Okay. So now once technical is okay, so when we go into a corporate field, so what are the different type of qualities that we want from the people who are coming? The first and foremost quality is communication skill. Do you agree? Do you all agree? Hello?
Yes, sir. Yes, sir.
Yeah. So why communication skill is so important? So basically, when we are today a connected world, you all know, at our times like 30-35 years back, we were not so connected to the world. Today we have almost everything is now somehow we are connecting to some of the other location in the world, and we are continuously interacting with the people. They are from the different race, they are from the different region, they are from the different languages and all that. So if you will not be able to communicate properly with the people, whether it is internal or external, it will be very difficult for you to really create anything. Because in an engineering design, you will be having a team, you will be working in a team, right? So when you are working in a team, if you are not able to convey your thoughts or your ideas so easily and so factually with the team, and they do not understand what you are saying, then everything goes haywire. And now I will just tell you what is the difference between this IT and engineering. So like everybody from the last 20, I think 2 decades or 2.5 decades, almost everybody who are graduating from whatever field, they were mostly running into the IT field, right? That was a trend we have seen. I'm right or wrong? Hello?
Yes, sir.
Yes, sir. Yes,
Yeah,
sir.
everybody was rushing towards IT, right?
Yes,
So,
yes.
so what happened actually over this 2.5 decade? What happened? The effect of this particular trend is this, that we have lost very good engineers. Actually, we wanted those core engineers. Now, how India will be a developing nation or developed nation? Can only IT can develop India?
No, sir.
No,
No.
sir.
We require basic infrastructure to develop
Yes.
India. We require bridges, we require highways, we require railways, we require factories, we require water, we require everything, all these things. This basic infrastructure is required. So now what is happening, the trend is reversing. Today, Tech Mahindra, I am giving you the names, already, I believe. HCL Technologies, TCS, L&T Technology Services or L&T Infotech, where they are moving, they are going into the engineering design now, and they are starting their own centers of engineering design. And why they are doing it? Because IT field is now getting saturated, and today really they are facing a lot of challenging times, but there is a huge boom in engineering design. So in engineering design, I will just give you some locations in India where actually if somebody is going into this field, where they have to go, in fact. So there are only few centers where you will find good engineering companies. One is the Chennai, where you will find most of the oil and gas companies situated, and they are having their design centers. Second one is Bangalore. Bangalore is still, I would say, it is into the product design, not on the process design. Then the third one is the Gurgaon, NCR region, where a lot of good companies, MNCs are there. And the last one, and Mumbai. Mumbai, you will find a lot of companies, good companies, and Vadodara, where I am situated right now. So in Vadodara, because it is actually almost becoming a design hub, and almost all kind of MNCs have opened their shop here. So you will find a reasonably good chance to have working opportunities here in Vadodara, and it's a small city, so it is easy to live. So this is what it is. So in India also, you have got very few areas, or few locations where all these good design engineering companies are located. So you can choose from them. So this is something I would say on the soft. So on the technical side of it, I just actually touched upon. Then on the soft skill type of on the soft skill side. So when we say communication skill, so then the next one comes as a leadership skill. So leadership skill, you have to show that leadership skill in your team and in your organization, so that organization can give you a chance to go to a ladder to reach to go step by step to the next level. Then only you can really reach to a level where you can see, you can find your place, good place, and you can build your career. So this is something just wanted to give a brief on this. And then I think basically when we say we are an engineer, so I don't know how many of you really know what is an engineer mean. Can anybody tell me what does this what an engineer mean? How you are different than a common man?
So managing most of the things at the same time and designing something is creatively is an engineer.
Okay. This is not only the definition of engineer. Basically, what an engineer mean, you have to optimize that design. So designing per se is not only the requirement of an engine from an engineer. Basically, it should be economical. So when you are creating something, if it is not saleable in the market, what you will do, right? You will be only proud of yourself that I have created something great, but you are not able to sell because ultimately you are into business, right? So what I will suggest, as an engineer, you must also know something, some basic economics. And the person who understands little basic economics will be a great engineer actually, because engineering plus economics becomes entrepreneur. So when you become entrepreneur, when your thought is from the entrepreneur side, then any corporate world or anywhere you go, they will love it, because that is what everybody want today, right?
Yes.
Whenever you are going into a company, they are not taking you for just doing some work or something like that. That anyway anybody will do.
Yes.
What they are expecting from you, that what kind of innovative thing, your creative thing you are doing, and with that how you are improving the productivity, how you are actually creating something which is unique. Okay, because you have to give a unique proposition, you must have something, right? Because so many companies are there outside doing almost same thing. So how you will survive in such a competitive world? So when we say how you will survive, the only thing is your innovativeness, your creativity, and your understanding of the business dynamics. That plays a big role. So if you are having that kind of a thought process, apart from the normal what you are doing anyway, then it will give a greater chance for you to really have a great career in wherever you want. Means I'm not saying into design is everywhere. So this is something I will suggest, that this should be like this. So I think I've given you most of the, you can say, experience, my experience and knowledge and all that. So here I believe I can stay. But actually, I wanted to create some presentation, but I could not manage that because of my too much of busyness into my field at this moment. So anyway, you can even send your questions or queries or something like that through to my email, and I would like to. And I will be happy to reply on that. So. Anything if you want to ask now? So we are almost, I'm almost done at this moment. If anything specific you want, you may please ask, or you can send an email also.
Sure, sir. Definitely, this session had a great. We had a great
Hello.
experience with you on this session, going live through internet, and you have also taken your important time and sharing your valuable knowledge with us. This session will definitely help our students of Sanjeevni to reach greater heights
Hello.
with the help of you.
Thank you.
Yes, sir. You are audible,
Hello.
sir.
Sir, just this is Professor Prasad Bosge, Department of Mechanical Engineering, sir. Hello,
Okay.
am I audible?
Yeah.
Sir, just on behalf of students, I would just want to ask one question regarding the green hydrogen and its future and
Okay.
opportunities.
Okay. So basically, green hydrogen, I would say, I will just give you a brief about what is green hydrogen, and then we'll go into the opportunities and current status of it. So green hydrogen is basically the production of hydrogen using non-conventional sources of energy. So if suppose you are having a solar farm, or you can say wind farm or something, so you are using that electricity and you are doing electrolyzers, and in electrolyzers you are actually converting water into hydrogen and oxygen. It's a normal simple process as is it seems to be, but the complication of this process is very slow, and if you will doing this, you will not get that kind of a yield which will be commercially possible. So therefore, there are a lot of R&Ds happening in developing very, you can say, efficient and higher output giving electrolyzers. And so this is something area that is now developing. So, and in India, because government of India has allocated almost 20,000 crore for green hydrogen mission, and many of the companies are now coming forward, whether it is small or big or whatever, and many of the companies who have already got solar farms in India, mostly in the rural side, so they are taking that hydrogen and they are trying to generate hydrogen there. So basically the investment, hello, I'm getting a lot of disturbance. So basically, in India, lot of big conglomerates like Reliance, Adani, and Tata, and all those kind of things, they are putting lot of big plants actually for green hydrogen. But of course, there is a big challenge in green hydrogen. The challenge is you can only convert pure water or DM water, that is demineralized water. So from where you will get that water? Because if you will demineralize it, ultimately what you are doing, you are actually spending more energy into it to demineralize it. Suppose you are taking groundwater, the TDS levels are almost 2000, 3000 sometimes in the rural areas. So you have to do lot of softening of that, and then only hydrogen can be produced. So there are a couple of challenges at this moment in this particular area, but many companies are actually developing a lot of R&Ds happening in this field. And very recently, we have also completed one green hydrogen project. And this hydrogen is basically then compressed once it is produced up to 200 bar or sometimes 500 bar. And they are being filled into cascades, and then they are generally used in various agrochemical industries where hydrogen is generally used for synthesis gas. So this is how actually currently happening. But yeah, this area is evolving. A lot of investment is happening, and I see a very bright future of green hydrogen in India and abroad both. I hope I've answered.
Thank you, sir. Thank you very much.
Now I would request the students to please go further. Please post their questions in the chat box, or directly they can come up with the mic.
Sir, we have a question in the chat box. How do you handle unexpected disruptions in the manufacturing process?
Uh, I'm not really getting what exactly you want to say. Means is it something like something has broken down, something as you were saying like that?
So the question from Ketan Munde. Uh, how do you handle unexpected disruptions in manufacturing process? I
So the unexpected disruptions might be the
Okay,
natural calamities or etc.
okay, that way you are saying.
Oh
Okay,
yes.
so basically, yeah, so basically what happens when we do design of any manufacturing plant, so there are a lot of safety aspects needs to be taken into consideration. So safety aspects are coming from the two or three different areas. So one is the environmental factors like seismic. So suppose there is an earthquake, and during the earthquake, suppose your plant collapses, and because of that, there is some due to this accident, there is a larger accident happens, like there is a fire or explosion happens and something like that. So that is something on the environmental side. The other side is on the operational hazard or operational issues. So what we do when we carry out this design, we generally do a lot of studies. So in the studies, a couple of studies I'll just name, and you can even search on the Google. So the safety studies are basically hazard, that is hazards identification, then HAZOP, that is hazards operation, then there is SIL, that is safety integrity level, then there are QRA, that is quantitative risk assessment. So these are all a couple of studies we do, and there are a couple of softwares also available to carry out such studies. And during these studies, we generally create a lot of scenarios. In the scenarios, like he said, yeah, there is a disruption. So suppose such kind of a thing happens. So what will happen to the plant or to the manufacturing process or whatever? So when we carry out such kind of a thing, and suppose there is a disruption happens, so there are controls we are giving, like instrumentation and control. You must be having your fellow friends in I&C department, so you can talk to them what they are doing exactly. So there actually what we do, there are a lot of control loops we give. So once such kind of a thing happens, we also call emergency shutdown systems. So in the emergency shutdown system activates, and that activation actually stops this manufacturing process immediately, and all the upstream side of that particular disruption gets disconnected, and there how we actually immediately stop the plant, and then we correct, do or whatever corrective action is required, we correct it, and then again restart the plant. So a lot of operating and shutdown procedures are generally created, and it is a very long process, and it's a main thing in any engineering design. I hope I have answered it.
Yes, sir, definitely you have answered the question of Ketan. Sir, we have one more question from Harshal Gagre, that what materials have you found most challenging to work in within the 3D printing, and how that can be overcome those challenges?
See, I'm not into that area of 3D printing, so I will not be able to answer this question. See,
Okay,
let me tell
sure,
you
sir.
one thing.
Sir, as
See,
we
let
are
me tell you one thing. On 3D printing, I will just give some small brief on that. Basically, 3D printing is currently, if you will see, of course, it is a new developing field, and most of the time, like product, particularly it comes under the product design, because generally you create small products out of this 3D printing, which are generally directly used into various areas. So the composite material, no? So that is something which is highly durable, and which has good mechanical properties like tensile strength or wearing strength and all that. They are little difficult to really do this 3D printing, because 3D printing can be done with those materials like the plastic materials or sometimes the cement material, which are very easily moldable, and which requires very less energy to convert them into some shape. So these kind of materials are easy. So otherwise, I don't have much knowledge on 3D modeling, on 3D printing.
Thank you, sir. So we'll move to the next question, which is asked by Rutuja Gosavi, and this is the last question of our session. And rest of the questions will be emailed to you. So the question is, what are the key advantages of additive manufacturing?
Additive manufacturing. See, advantages, I wouldn't say this is something, not something, the question is may not be on that side. Basically, additives are basically the chemical components or compounds which changes the property of various normally useful you can say chemicals. So we do a lot of such designs for such plants. So these are basically a process. This is basically a process. So additives are used into paint industry or into the chemical industry, agrochemical industries, and all similar type of industries. So these actually changes or enhances the property. So this is something that happens actually. That's what, and we call it specialty chemicals basically into the engineering no terminology. So that is how it is basically, and these are also used in pharmaceutical.
Thank you, sir, for providing such a great knowledge to our students. And a feedback form link is shared in the chat box. Student, please do fill the feedback form, and your questions and your feedbacks are valuable to us. And also, the attendance of this session will be given through that feedback form. So please do fill it before the session ends. And now we will proceed forward.
Um, I would like to ask Prasad Bozge sir to give away the vote of thanks.
Hello, sir. Am I audible? Hello.
Yeah, yeah.
First of all, on behalf of the Honorable Management Sanjeevani Group of Institute, I would like to thank Arvind sir for giving your valuable time. Again, you also gave very good insight in the engineering design and like process and product design, and what the qualities are important for the fresh engineering graduates, so that they can be good engineers in the core sector. As you rightly said, instead of IT, our country really needs good design engineers in the core field. Again, on behalf of the Director, Sanjeevani College of Engineering, and our HOD, Dr. PM Pathare sir, I would like to thank you once again, and I would also invite you to our campus so that we can have a interactive session in person. Thank you very much.
Thank you, Mr. Prasad, and I will look forward to visit college because I also want to see the college again. Because after 30 years, probably it might have changed a lot. So definitely, someday, definitely I will plan.
You are most welcome, sir.
Thank you all. Thank you, students, and best of luck for your future.
Thank you, sir. Now that we have come to the conclusion of this amazing online meet, I would like to express my heartfelt thanks to Arvind Shajapurkar, sir. Looking forward for more sessions with you, sir. Thank you.
Okay. Thank you. Thank you. Bye. Have a
Thank you.
good day.
Have a good day, sir.